There is a very important concept called polymorphism in object-oriented programming languages. So polymorphism is a difficult word, basically means many different forms. And in Java, it was implemented. Polymorphism was implemented using interface. Every time you see that interface is used, you should know that now there could be many forms out there for this interface. What we see here is this interface, but behind the scene, there are many different forms for this same interface. The interface defines what can be done with a class, right? An interface, the definition of interface just tell what can be done, right? But not how it can be done, right? So for example, interface define a behavior called move. It basically tells any class that implements the interface actually can, this object of that class can move. That is the behavior. But how does this object move? It was now defined by interface. So interface defines what can be done, but not how it can be done. Okay. So when the program runs, so the behavior, how it can be done, depends on the actual class. For example, you have a fish class that implements this interface with move method in it. So the behavior of move for fish is going to be swim. If you have a bird class, so the move behavior is actually fly, right? If you have a dog class, it's going to be just walk or run, something like that. So the behavior depends on the actual class. But we all know that what all of these can do. They can all move. But how do they move? It depends on the actual class. Okay, so the same behavior, the move behavior could have many different forms. Could run, could be walk, could be fly, could be swim, could be some other, right? Like that. All right. So this we call this polymorphism. So every time you see move, this you should understand that behind the scene there could be many different forms for this the move interface that you see, even though they all call move, but they could be different behaviors. So again, interface is a way to define what classes should do, right? Without specifying how they should do it. And a class can implement one or more. Of course, zero. A class does not have to implement an interface, but if you want, you can implement as many interfaces as you want. For inheritance, only one superclass. For interface, you can implement as many as you want. Now you may guess. Now, if we know about interface to model wildcat student, we can let it extend student superclass and implement multiple interfaces for employee, parent, child, and many more, right? This is just another way to model a complex object like that. All right, so if a class implements an interface, the class is required to provide the body for those methods defined in an interface. Okay, yeah, so let's go ahead and start to see some real examples. Okay, I'm going to add a new project to show you all of this. I'm going to just call this Z30-30 interface. Okay. Again, it's up to you on how you want to do it. You can just look at me on how I do it, or you can follow my example and do it at the same time with me. Either way is okay. However you feel comfortable. Okay. Yep. So I'm going to, I probably won't add any packages, but let me move away all of these, and so we can focus on. So last time, remember we worked on a machine example. Remember, let me bring it back again. So I have a public class machine that defines a piece of data is on, and it has three methods. One is a constructor, the other one is is turn on and turn off, the other two, right? I'm going to, in this case, I'm going to turn this into a interface. Okay, turn this into an interface and see how we can do the same thing to model a printer. Okay, so I'm going to add a interface. So now you can see if I add if I try to add a new Java class, there are several different options I can choose. I can choose a class, interface, record, or enum annotation, right? It's okay if you forgot to select interface. You can select class, that's fine. I'm going to call it iMachine. I start this name with a capital letter I. This is a naming convention very commonly used in C#. I have to make this clear. In Java, some professionals follow this naming convention, some don't. So this is not required. You don't have to do this, but I just prefer to do that because it is used by many C# programmers. This I here, capital I here, means interface. So this is going to be an interface called machine, iMachine. Okay. So I add this. I forgot to select the interface as a type, but that is okay. I can change this class to interface. I can just retype the keyword, and now I'm turning this into a interface. Okay. And then now what I need to do in this case is to define a set of methods for this interface, a set of methods. Okay. And if you take a look at the left pane, you will see that now this interface file has a special icon, a capital I inside of a green colored circle, right? You see this, you know this is the interface definition. Okay. All right, so let's go ahead. Add some methods. Void turn on, and followed by a semicolon, and the void turn off, and the boolean is on. Okay, and by default, all of these methods are public. They have to be public. They cannot be private or protected. So we can skip the public keyword, but if you want to add it, that's fine. That's perfectly okay. But just so you know that this public keyword is optional. Okay, it's optional. So now we're defining an interface. You can see that this interface defines 3 methods without any bodies. There's no concrete implementation of these 3 methods, right? And this interface defines what other classes should do, but not how to do it. It all depends on the concrete class that implements this interface, right? Now let's go ahead and redefine the printer class. So I'm going to add a new Java class printer. And in the past, I'm using extends to extend a superclass, but now I'm going to use implements to implement a interface, iMachine. Right? Implements iMachine. Now we immediately see the error message. This red colored line indicates that there's some arrows. Let's hover over it, and IntelliJ will provide a way for us to fix that. So we can see implement as methods. We click that, and all of the 3 methods are selected, and click OK. And those methods will be inserted by IntelliJ. So it saves us some typing. And now you can see that this printer class implements the iMachine method. So this class is required to provide bodies for these 3 methods. Basically, the class needs to tell how these 3 behaviors can be done, right? How to turn on this printer, how to turn it off, how to tell whether or not this machine is on. Right? Yeah. So now let's go ahead and add some other data members for this class. Private string model number, just like last time, and private, okay, capital S, sorry. Private boolean is on. Okay, so once we add this, we can keep adding some constructors. Let's go ahead, right click and add a constructor, generate constructor. So I'm gonna select both of these two member variables, and the constructor is added, so we don't have to type. Okay? And now it's time for us to implement these three methods. And for turn on, I'm going to just display message, print out. So the printer, we can say warming up printer, something like that. And then we assign true to is on. So is on is one of the member variables. For turn off, I'm going to just display another message. So the printer is turning off, and then I'm gonna assign false to is on. Okay, and then for is on, I'm gonna return is on. Or if you wanna to be more accurate, you can say this dot is on. Right? And it's okay. I'm using a member variable name that is the same as a method name. That is okay. The compiler knows which one is which, because the isOn method will be followed by a pair of parentheses. The other one isOn will not be. Right? So it's very easy. It's perfectly okay if you use the same name. Okay, same name. Yep. So this is a new design of the printer class utilizing the interface technique. Right? Interface technique.
Class other methods that aren't part of the interface?
Yes, you can. You can add some other methods. For example, I remember we have a method called print, right? Void print. Yeah, you can add some additional new methods in this class which are not defined in the interface. Perfectly okay. We treat those methods as new behaviors for this class. But if this class implements this interface, the class is required to implement all of the methods defined in that interface. But we can add more, right? We can add more new methods not in the interface. For example, print. So we can, it requires a int number of copies. We can say string text to print equals empty, and we can add the model number. Oh, okay, print. I can say printer with model number plus model number, and I can use a while loop. While copies is greater than 0, I'm going to print this to the console. Text to print, and copies minus minus, right? All of these. Or what you can say while copies, okay, that's fine. We don't have to check to see if the printer is on and so forth. But yeah, you can see we can add more new methods. Okay? Yeah, this represents how we define our own interface. This iMachine is defined by ourselves, and there are many existing interfaces defined by the Java JDK library. It came with the library, and we can directly utilize them. Right? We can directly utilize. And let me show you one example. Before that, let me just go ahead and add another interface. So for example, Java class, this time I'm going to let interface, I'm going to call it how can I say this? For printer, I'm going to say iScan interface. What this interface defines is just one method, void scan, right? Something like that. iScan. So I can let this printer class implement multiple interfaces. I come back to printer, again, iScan only defines one method, scan, and come back to printer. So I'm gonna, right after iMachine, I have a comma, and I just add iScan. Right? You can keep adding more and more interfaces. So this will make this printer class a very complex class to have all of the behaviors defined in those interfaces. So of course we are required to implement that method. I'm gonna let IntelliJ insert scan, right? Like that. Remember last time we have a multifunction scan printer which can scan documents, can do faxing and so forth, and we can utilize interfaces to achieve that. Right? So scan, I can say display a message, scan a document, something like that, right? Yeah, this is how we can implement multiple interfaces. Use comma to separate them. Right? So if we need to define a wildcat student, we can do something like this, wildcat students. So this still extends student class, but it can implement, for example, you can implement I employee. I don't have any of these classes in this package. That's why you see red color, but I want to show you the way we can do it. Implement employee, I employee, I parent, I child, and any other. Let me see. Yeah, like that. So we can, this is how we can use the interface to model wildcat students. To include all of these behaviors and data from student class, employee class, iParent, and iChild interfaces, right? Employee interfaces, all of these. Right? This is how we can model. And this is easier and clear, more clear than the utilizing composition, because we know that the wildcat student is a student, is an employee, is a parent, and is a child. Right? You can keep adding more. If there's no more, don't add comma. So that's why it can be employee object, it can be parent object, it can be child object. Right? It has several identities in this case, several types associated with this wildcat student. Right? Yes. So this is how we can define our own interface. Pretty easy. Keep in mind, always define a small number of methods. Do not put like 10 methods, 20 methods in one interface. Any class that implement that interface is going to be a big burden for them, right? Just don't. Usually it's perfectly okay to have only one method in the definition of this interface, or two or three. Very commonly, we see up to 3 methods, or 4 at most, but not more than that. You don't want to have 10 methods in the interface definition. Any other classes need to implement all of these 10 methods. Is not going to be a pleasant thing for the programmers. There is no need to have very big interface. If you need to have 10 methods, divide them into 3 different interfaces, right? And to keep the interface small enough. That is the professional advice. All right, so now next I'm going to show you some existing interfaces that came with the JDK, Java JDK. Okay? And we can have a better understanding what are available out there and how we can utilize some existing interfaces. So I'm going to add the student class. Okay? So I'm going to add some private members, for example, private int ID, private double GPA, and private string major. Let's just use these 3 as the data members for the student class. So I'm going to add a constructor. constructor. I'm going to take keep all of these three, and there is a way to automatically initialize the ID, but I don't take that method. You all know how to do that. We use a static member next to available ID and assign ID to with that variable. Well, yep, let's go ahead. Now we have this constructor. So I'm going to add setters and getters to it. I don't want to type. I just select the generate getter and setters and select all of the three and click OK. Right now you can see I don't type a lot, but I can add a lot of code to my program with the help of this IDE, the Grid IDE, right? All right, now I have this my student. So what I want to do next is I want to compare the students. So for example, I'm going to add a main method. I'm going to construct several, or I can create a student test from here. Student test, this is just another class that has the main method. All right, so I'm going to create some students object. This time I'm going to use a simple array students post new student. I'm gonna use make the size of this array being 3, so I can keep adding. So I can say students, the first one, and then create new student. So we need to provide three parameters: ID, and first one is 1, 2, 3, GPA 3.5. Major, I'm gonna say computer. Engineering, and let me just copy paste this line 2 more times. I'm going to change index to 1 and 2, and ID is going to be 224 311, something like that, and J 8 9, and change your majors to 6, 3, like that. Now I have these 3 students, and I want to sort them probably based on their ID or based on their GPA and based on their major, right? There is a class called arrays. This class has a lot of utility classes utilities methods for us to use. For example, one is sort. I can pass in this array students and let arrays sort it. So I need to import this array. Now from Java util, array has been imported by IntelliJ. Let me show you how I do that. Many students ask about this. Now you see this error message. I position my cursor right here and press Alt and Enter key, and to activate the content assist and select import class. Right? Never ever type import statements by yourself, because it's difficult. Sometimes you don't know where this class is coming from. Let IntelliJ help you do that. Okay. Yep. Now array sort. So I'm going to display the so I'm going to say students. So I'm going to display those 3 students to the console, and I want to see the results. So let's go ahead and run it. So webcast student doesn't work. Let me comment out this. Public class. Let me just put an empty class right here. Otherwise, my code will not run. Yep. So now I'm going to come back to student test. I'm going to run this code. Let's click this play button and run this. Okay, the program crashed. It does not run. Even though the program compiles successfully, there's no syntax, but this line number 11, because it says student test Java 11, this line has issues, this one. If you look into the message, it says class student cannot be cast to class Java long comparable. Basically, the reason why the line number 11 failed to sort students objects is because the sort algorithm does not know how to sort your student, because your student is a complex type. It's not integer, it's not double, it's not something that the compiler knows about. So the compiler doesn't know how to compare students, how to sort them. Which one is a bit smaller, which one is larger, because everyone has 3 pieces of data: ID, GPA, and major, right? In this case, that's why this line 11 doesn't run. It doesn't know how to sort the student objects. So in this case, what we can do is we can actually implement an interface to let students implement an interface so that we can sort the student objects the way that we want. You can sort the student object based on however way you want to, but let me show you one way. So this is implement comparable and student. So comparable. So if you see something above, this is this is a Java naming convention. Java like to use something comparable, clonable, sortable, runnable, all of these, right? Comparable again represents an interface defined by the Java JDK. It is a generic interface. We'll talk about generic programming after the midterm project. So in this pair of square angle brackets, so we need to give it a type. Comparable what? Students are going to be comparable. So that's why we put a student type. This is the student that we want to compare. So we're going to put a student type inside of this pair of angle brackets. So this comparable interface works with any type, but we just have to tell it which type it is working with right now in this program, right? In this program, it is going to work with the student type. In another program, it can work with a person type, with a bank account type, with a shape type, with anything. You just need to specify it. So now we're going to hover over it and select implement methods, and compare to is the method defined in that interface. And select that and let IntelliJ insert this for us. If I come back to comparable, I'm right click and I'm going to select go to and declaration. I'm going to show you that this is the definition of that interface. Public interface comparable T, this represents a generic interface. There is only one method, compare to. With another type, with a argument of the T type, in this case T is student. So that is going to be our target that we want to compare to. Public int. Int is a returning value. Take a look at this. The return value is going to be a negative integer, 0, or a positive integer. If these two are the same, it's going to return 0. If the left one is less than the right one, it's going to return negative. If the left one is good, it's going to be greater than the right one, it's going to be positive, right? Just want to tell you this, what is going to be the returning value, and I'm going to close this one, and let me come back to the compare to. So in this case, it's up to us what we want to compare. We can compare GPAs, we can compare IDs, we can compare their major. But let me show you one. Let's compare their GPAs. Okay, so I'm gonna use return double dot compare to. So double is a wrapper type for a small double type. So I'm gonna use compare to compare method. I'm gonna use this GPA compared with other GPA. So there is a method defined, not other, sorry, this is O, so I'm going to use O.GPA. There is a method defined in the double class called compare. So this is going to return the same integer value as compare to, required by compare to. If these two values are the same, it's going to return 0. If this GPA is less than O.GPA, it's going to return you a negative value. Otherwise, it's going to return you a positive value. Okay. Yeah, this is how we compare students. We just compare their GPAs. Okay. Now I'm going to come back here to run this program one more time. I'm waiting for it to run. I don't want to see this annoying crashing info. I want to see some students printed. All right, it's printed. It's not in the way that I want. I'm going to make a modification of this code. I'm going to say for student in students. I'm going to print the student. So I'm using a enhanced for loop, a simplified for loop. For this array, I can, for student, called student inside of this list of students, I'm just print it out to the console. So hopefully you should have learned that in 1400. If not, I can give you more example. We're going to use this a lot in future, and so that we don't have to write a very complex for loop. Okay? Yes, we also call it for each loop. Oh, I'm still printing out their memory address values. That's not what I want. So I'm going to override the toString method. So I'm coming back to student class. I'm going to right click and select generate ... I'm going to select the override methods. I'm going to select toString. Click OK. I'm going to return something nice. Rather than their just memory address value, which is useless for me, I'm going to return this. A student, I'm going to say student ID equals plus ID plus comma GPA equals plus GPA plus comma major equals plus major. Okay, that's what I do. I just print their ID, GPA, and major. The string is going to be returned every time if a string is needed for that object. This is going to be the one that is returned. I'm going to use student colon, but it's okay. This is not a very important. I'm coming back to student test, and I'm going to run it again. Okay, very nice. Now I can see student ID is this ID and that. Now you can see that the students are sorted based on their GPAs, right? From the smallest to the largest, right? In order. If I go back to student, now this time I'm not going to compare their GPAs. I'm going to compare their IDs, right? Maybe I can do something like this: return integer. Let's compare this .id with the other .id. I'm going to run out the other line, and now I'm comparing their IDs. So now I'm going to run it again. I can change the behavior of sorting based on the implementation of the compare to method. Yeah, now I can see now they are sorted based on IDs. 123, 224, 311. Right? Not on GPA anymore. Actually, I can also sort them based on the major. Right? Based on major. How would that work? Because it is going to be sorted based on the strings. The first line will be compared first. So C is the smallest, H is the second, and S is the third. Okay, let's do that. So I'm going to I'm utilizing the compare to method overwritten in the string class to do the job. Right? I don't have to compare them. Which one is smaller, which one larger? I don't have to do that. I just leverage compare to method defined in the string class. All right, now you can see their students are now sorted based on the major, basically based on their first characters. If the first characters are all the same, they can compare the second character and so forth until they find a difference, right? See, C, H, and S, right? Sorted like that. Yeah, let me implement another interface that came with the JDK, part of the library. Now we implement a comparable, so we can compare our student objects based on whatever we want to compare. And now I'm going to implement a so-called clonable. So clonable is not a generic interface, so we don't have to specify student like this. We can just add it to the list of the interfaces for student class. Now you can see we do not see any error messages because the clone method is actually one of the methods defined in the ultimate superclass object. Remember, we have this object class, right, which is the superclass of any other Java classes. If I right-click and select generate and override methods, you will see that clone is actually one of the methods together with equals, hash code, and a super constructor finalizes for multi-threading. And we do not see toString because we have overridden toString, so we do not see that in the list. The list only shows us the rest available methods we can override, right? So I'm going to quickly show you. If I say student extends object, I need to have. So I'm gonna go to the declaration of this object superclass to show you the clone method. Clone, we all understand, is just make a copy, right? Just make a copy of the object. And if I go to, where is clone? It is right here. Yep. So subject clone method is a protected method. Is a protected. For many other methods, they are public. So for toString is a public, notify is a public, equals is a public, but clone is a protected method. What does that mean? Protected method. A protected method is almost like a private method. It's only available inside of the class itself and all of its subclasses. Meaning that yes, the clone method is available inside of the student class, but is not available outside of it. So for example, if I go to student test, if I do something like this, students, the first student.clone, I don't have that method because I am now outside of the student class. The clone method is inside of student class, is available inside, is protected, right? Why it is protected and others are public? The reason is because clone behavior is a class-specific behavior. What does that mean? So we have actually two different types of copying behaviors, shallow copy and deep copy. And it's up to the class. If you make the clone method public, it's very easy for programmers to make a mistake. When they want to use a shallow copy, now we have a deep copy, or they need deep copy, and then we have shallow copy. In most cases, what they need is a deep copy, but actually the clone method actually can only provide shallow copy in that case, right? That's why it is very important for every class to redefine that behavior before making it a public. Right? So we have, what does that mean, shallow copy and deep copy? I'm not sure whether now 1400 covers that. I guess probably not. But let me tell you, shallow copy means we copy all of the references, but not the object that the references refer to. For example, if I say this student has a private circle object, I don't know why a student has a circle in it, but just let's assume that student has a circle, right? So this circle, like on day one, we talk about it. This circle basically is a reference that refers to or points to a real circle object in the memory. The shallow copy means let's just make a copy of this reference. What we copy is just a memory location. Something like you write down on a piece of paper your mailing address, and you make a copy of that paper. That mailing address refers to your house, right? That address actually refers to your house. If you make a copy of that piece of paper, you're making a copy of that reference. Say, if you want to make a deep copy, you actually make a copy of your house. Those two are different. You make a copy of that piece of paper, you're making shallow copy. If you make a copy of your real house, that you're doing a deep copy. In most cases, deep copy is preferred because think about it. If we want to make a copy of these student objects, and if we only do shallow copy, if we only copy the references or that piece of paper, and that piece of paper can be used later, can point to another house, right? Very easy. Say, right? I can take that piece of paper, scratch out your address. I can put down a new address. This new address refers to another house, which is not the one included in this object. So if we make a shallow copy, all the references can later point to other things that we don't know, right? That's why if we really want to make a copy of something, we want to make a deep copy, but not shallow copy. That's why for simple values, for integer double, that is fine. Shallow copy is the same as deep copy, but for complex objects like circle, shallow copy is not the same as deep copy. That is why the clone method is protected. It requires you to change its behavior before it becomes public for other people to use. You have to correct the behavior. You have to implement the correct behavior for copy, for clone, before making it public. Right? Let me show you how we can do that. Now I want to make the student clonable, or I want other people to make copy of the student objects, so I decide to implement the clonable interface. So I'm required, of course, to implement that method. I don't know how to type the signature. That's why I'm going to go to generate and override methods. I'm going to select clone method and click OK. The first thing I do is to change protected keyword to public. Otherwise, everything I do is going to be useless because the public cannot access that. Other part of the program cannot access a protected method. Protect is only available inside the student class or any other subclasses using student as a super class, right? So the first thing I do is change from protected to public for clone. And now I'm going to define the deep copy for the student object. Say I'm going to have, let me go ahead and add another. Right now, I don't have really complex type of the data. I'm going to add private local date, higher date. So this is going to be a complex type that requires deep copy. And I'm going to go back to my clone method. For other parts, I know that it is going to be fine. String, it is okay. Deep copy, shallow copy, the same. For int, for double, same. Nothing I have to worry about. I just need to worry about the local date. I need to make a deep copy of that real object, not just a reference that refers to a local date, because later the local date reference can refer to another date, right? And the hiker can have a way to change the hire day of any student. Well, I cannot call it a hire day, right? Because it's a student. This is not an employee. I just realized it. I'm going to call it a registration day. Registration day, how about that, right? This is when the student registered with the school, right? Registration day. For employee, we have a hire day. Yeah, that makes more sense now. Yeah, now, so I'm going to create a student object cloned equals. I'm going to call the one defined in the super class, super clone, or I can create a new object. So either way is fine, because in this case, the super class is just the object class. It is going to shallow copy, but that's fine for some other, for name, for ID, for GPA, that's fine. But one way you can do it, you can do something like this, new student, that is fine. And do I have a, okay, I'm gonna use the current ID and current GPA to initialize it. Does it require any other thing? Major, okay. I'm gonna use the current major to initialize it. So I have a new object cloned, and very importantly, I need to clone not hire day, registration day equals this dot registration day dot clone. Oh, I don't have that method. Give me 1 second. I'm gonna change this from local date to date. I forgot the local date is an immutable class, just like string. So for immutable classes, shallow copy and deep copy are the same thing because they don't change. And so I'm going to change to date. So date is a legacy or a historical date type. It's old. I do not recommend you use it, but in the legacy project, you may see that. I'm going to change it to date. Now I'm going to the where is the date? Yes, so I'm going to come back here, clone registration day, this registration day dot clone. Cannot Java UT. Okay, let me see, I may utilize the wrong Java util date. That is correct. So compared to, I'm going to get rid of this one, cloned dot registration day equals this dot registration day dot clone. Yep. Why does not allow me to? Okay, I'm gonna have to change it to date type. Okay, got it. This clone method actually returns a object type. So I have to cast it to the date type because I know this is a date type. So I'm calling clone method to make a copy of this data object and assign it to the cloned registration day. If I don't do that, if I do something like this, we call this shallow copy, because what we are copying here is just the registration, is just a reference or the memory address value. Right now, you can remember that example I gave you. Circle A equals circle B. Now circle A and circle B, they both point to the same circle object in the memory. If I do this, so the clone registration day and the current registration day, they both point to the same registration day object in the memory. We are not making any copy actually. So we are just let these two refer to the same data object. If we change one, so we're going to change the other. So this is not a copy. Oh, this is a shallow copy. So that's why we have to let this make a copy of itself and assign it back to the cloned object. Right? So this is very important. Otherwise, you will run into all kinds of issues. And you have potential bugs, and you never know. It's very hard to detect that. That's why this clonable is defined as a protected interface in the automated superclass. And at the time you want to make your object clonable, you have to override it, make this method public, and define the correct behavior. Right? So I'm coming back to student test, and now I'm going to make copy. So I'm going to say student copy equals students. I'm gonna make a copy of the first student object, and I'm gonna say clone, right? Now it's working. So this one clone is gonna return no. I'm gonna put student type. I'm gonna cast this student type. I know it is student type. Still not happy. Handle exception. I'm gonna add exception to signature to throws clone not supported. Don't worry about exception. We'll talk about it. Okay. After 2 weeks, we're gonna cover exception. I don't think I need to make a casting here. Oh, we still need to make casting. Let's come back here. Is object type. I'm going to change to student type so that I don't have to do casting because I know the returned one is the student type. I'm going to have to return the, I'm going to have to remove super clone. I don't do that. I'm going to return cloned. I'm still inside of the student class, the clone. Now I'm done. I'm coming back to here. I don't need to cast it anything. Yep. So this is how we can print, copy, right, like that. I just print the copy, and let me show you these two are the same. But they are the same field value doesn't mean they are the same. They just copy. They are just one is the copy of the other, and if you change one, that won't affect the other. Okay. This registration date is, oh, okay. I didn't give it a value. Okay, let me just give it a value. It does not give me. So it's complex. We have to use Gregorian. Let me just do that here inside of this. Okay, we need to create a new Gregorian calendar and calendar. Registration date equals calendar. Start to date. Yep, so let's go ahead and run this. And hopefully we can see some date information. Yep, now you can see that the copy has been printed. We didn't print the date information, but copy has been printed. It's a copy of the first student object, which has ID 123 and GPA 3.5. Yeah. Right. Yeah. Let me show you, since we still have a little time. Let me show you another commonly used interface that came with the JDK. It is very heavily utilized, very commonly utilized in graphical user interface applications. Okay, yeah, let me show you that. We call it time printer. So I'm going to add a new Java class and call it time printer. So this class, I'm going to implement interface called action listener. So action listener is an interface defined in the Java JDK that can be used to listen to an event. I'll explain that. Let me go ahead and just add the implemented method. It just requires one method action performed. I'm going to add this method. So any class that implements this method can become a listener. For example, time printer, this class implements this listener, action listener interface. So any object of this class can become a listener. What is a listener? So in a event-driven environment, a listener can register with some other objects that can shoot out events. Right? For example, this listener can register with a button. If the button is clicked, it's going to emit button clicked event. and that event will be sent to all the registered listeners. This is how the graphical user interface application is working. So this time printer can register itself with some other event initializers. So once that event occurs, this guy will be notified and will do something. What it's going to do is defined by this action performed method. This is define the behavior of this object, this listener, when the event occurs. So let's see what is going to do. So I'm going to say action performed. I'm going to say local time now equals local time now. Okay, and I'm going to say print some message at the tone. The time is. You may wonder, we were talking about local date, right? But local time represents hour, minutes, and seconds. Local date represents year, months, and day, right? So we have two. Previously, we talked about local date, right? Now we are using local time, almost the same as local date. Very easy to use, immutable class. And this is new defined after Java JDK 8. So this is highly recommended to replace any other date type of objects, so local time. So because we need to utilize hours, minutes, seconds, so we're going to use local time. Okay. The time is now, and then I'm going to use the toolkit dot get default toolkits dot beep. So this toolkit is referred to the Windows or the operating system. Get default toolkit is going to get the default toolkits resource from your operating system. It depends on it doesn't matter what operating system you use, and Java Virtual Machine is going to handle that to get the toolkits to make a beep sound to the system. Okay. Yep. Now I'm gonna. So this defines what this listener is going to do when the event occurs. So when the event occurs, it's gonna just display the message and let the system beep. That's what it is going to do. So now I'm gonna just define a main method. So this is the entry points of this application. So in this case, I'm going to define action listener, new time printer. Pay attention to this statement. It's very important because this time printer implements this interface. We can say that this time printer is an action listener, right? So it actually represents the inheritance or the relationship between the two. If I go back to student, the student implements comparable and clonable. We can say student is comparable and is clonable, right? We can say the printer is an iMachine and also is an iScan, right? That's why we come back here. We can say that the time printer is a action listener. That's why we can construct a time printer object and assign it to a action listener type of reference. Right? Yeah. So now I'm going to make this timer t equals new. So timer in this case, we can click here and Alt enter to import that from Java X Swing. So Java X is a new package for user interface. Java X.Swing is a new package for user interface. We're going to use that a lot in future in this class. So right now this timer is defined in that package because timer is very closely related to graphical user interface. So now the timer is the event initializer in this case. So timer is going to do something, and any action listener object can register with timer. So when the timer triggers a time up event, it's going to notify all of the registered listeners. In this case, this action listener here is registered with this timer. The first 10,000 is the seconds. is milliseconds. I'm going to make this 1000. So 1 second, basically. I'm using underscore here this is again a new feature. It represents how we can write a big number in Java. Previously, we just used this. But now we can use this to represent big numbers like that, right? To make it easier to read. But since this is not too much, I'm going to just use this. 1000 is 1 second. So every 1 second, the timer is going to be triggered and will notify all the registered listeners to do something. What does this listener do? Defined in action performed method. Okay, so now I'm going to start the timer. T.start. Okay, and now I'm going to add some graphical user interface components so that we can stop the application. OpenPaint.show message dialog. We can say the parent is not. Don't worry about all of these arguments. We'll talk about it later. And the quit program is going to be if yes, and system.exit 0. So system exit is a command to terminate this application. 0 means everything's okay. All right, so I'm going to I'm going to go and run this application. Pretty simple, short program, but it involves several techniques: interface, action listener interface, and action performed. That's what you see. Every second, the time printer is going to print the current time and make the system beep. You can hear that, right? I believe. Right? So where is that? Yeah. Yeah, it just jumped to another screen here. This is the little message dialog. You can click OK to terminate this program. Right? We can change it to 2000. So every 2 seconds, it make a beep sound. And not be every second. It's too much. And also, you can see that the time is printed. Yeah, now every 2 seconds, the time is going to be printed. Now you can see 14, 16, 18, 20, about every 2 seconds, right? And this little cute dialog is running, and we can click the OK button to terminate the program, right? Very simple user interface stuff, but what we want to show you is this action listener. So we're going to utilize this a lot in the graphical user interface design. So we can, any class who implement this interface can be a listener, can register itself with any other graphical user interface component. For example, you click button, some registered listeners will act on that, right? Or you click the menu bar, you click a menu icon, or you click a menu item, and the registered listeners will do something for you. Okay, yeah, I think that's all I need to talk about for interface. You can see, to summarize, the interface defines what should be done, but not how it should be done, right? For example, action performed, action listener defines that this is what should be implemented in this class, but not how. How to implement it, it depends on your time printer, how you want to do it.